ORTUR Laser Master 3 in the machine shop.
Probably the biggest question you have is, why do we need a laser in a machine shop that cannot cut metal? Well, I'm going to do my best to explain that to you in this video. This is the new proposed way of labeling the machines with nice diagrams, easy to see, nice and bright, and this is our old way. Hard to see, and they are all generic and look the same. This is the student tool crib. My goal is to be able to walk in here, or have anyone walk in here, within 30 seconds and be able to find what they want. Now, it's hard to tell, but each one of these cabinets are labeled. They are a little difficult to see. Could you imagine if we had a picture of whatever's inside the cabinet? Okay, countersink, so we had a picture of size and a picture of a countersink in color coordination so that we can tell exactly what this is. So if you want a tool for the lathe, well, all lathe tooling would be orange and all mill tooling would be purple or something like that. How much faster and easier it would be. Not to mention the faculty tool crib.
Because this video is quite lengthy, we broke it up into chapters so it's easier to follow. Some real cool safety features.
First of all, if we take a look, we have a key system. So if somebody wants to operate this and the key is in the off position, the machine's not going to turn on. So that's a nice safety feature to have as well. Also, if there's a situation, you can hit the e-stop, which makes things a little bit easier when people panic. And if you jar or lift up or bump the laser will shut off. And if the laser, for some reason, stops traversing and stays in one spot, which could actually cause a fire on certain products, the laser will shut down as well. Let's talk about glasses for a minute. You do need glasses or safety glasses when you're operating a laser. This is the pair that comes with the machine. I talked to my optometrist and he says these are perfectly fine, not a problem. But I thought, well, you know what, I want a nicer pair. So I went out and bought an aftermarket pair. These are nice, but what I didn't realize, and I never thought about it, is I require regular glasses. This style does not allow me to wear my glasses, but this style does. Okay, so I basically had to switch rooms. I was in a nice office before, so now we're going to do this in the welding room and the heat treating room, because we have this really cool ventilation system that we can turn on and off, and we can close the doors so that all of the smell or anything else stays within this room.
Engraving nameplates for the machines.
So this is the end result that I was trying to get. Now we will be changing the design up slightly, but I want to be able to look on here and say, oh, that's grinder number 3 or lathe number 5.
This is the general design that we decided to go with. Here's an example of it on the actual machine.
Okay, so now I'm going to just take these cards here and put them in place one at a time. So I can do up to 15 at once now. And the grid pattern here on this frame that I cut out earlier holds everything in place.
Okay, as you can see, it's not quite perfect. The number 2 is floating around a small amount, and the second 3 and 4 actually popped off the table. What I did to fix this is I put some two-face tape or carpet tape down to hold it in place, and that made a world of difference. This machine is capable of cutting 20,000 millimeters a minute, and it has a table space of 400 millimeter by 400 millimeter, or 15 3/4 inches by 15 3/4 inches.
So we had a little issue with these two. They popped out, and that's okay. So let's take a look. It's not that bad. We still have to clean it up yet, but that turned out great.
The trick to getting the perfect cut is marrying the proper speed and power setting for the material that you're cutting or burning. There are charts on the internet to give you a guideline of what your power setting compared to your feed should be. Do a couple of test cuts and you shouldn't have any problems. How to switch the laser from engraving mode to cutting mode and back again.
Let's switch from engraving to cutting. Let's unscrew this little thumb screw here, lift this off. You can unplug this and then it's easier to freehand, but you don't need to.
I've already removed the plug so I can install the air nozzle or the air hose. So as we go through, when we look down here, you see the small tab here, you might not be able to see it. And then the long tab. The short tab's the compression tab. So you just squeeze on here slightly and then it pops off. It's not much, just a very small amount. And then this large tab goes in first when you reinstall it. We take our air nozzle, screw our air nozzle into the bottom, finger tight, take the long tab, line it up with the long tab side, then pop on the other one, set this guy back on here. You will have to adjust your height when you use this as well. It does come with some air fittings and an adjuster here, but what I'm using is just simply an airbrush compressor, so very little air comes out and low pressure. Take our hose, install our hose, and that's it. That guy's on there, it's not coming off. And also we can mount our hose in if we want. So to put it back to engrave mode, just unscrew this here, push on the compression tab, unscrew our nozzle, put our piece back together, put this guy back on. Make sure we put our little plug back in here and we're good to go. Engraving everything, and I mean everything. Porcelain tiles. One of the things you might have to keep in mind is that the porcelain coating is not an even coating, and you might have to use more power than what you think you need. Okay, first successful cut. Looks nice and pretty. Slate coasters. The color that comes out after burning is a gold hue, and it looks incredible. That looks quite nice. And our cut setting is 1,100%. Wood and bamboo. So on bamboo, I'm using 15% and 100 inches a minute. And it seems to be doing a nice job with that. Here are a couple of examples of cutting boards that I recently created. There are all sorts of free software online. To create this one, we used one called WordCloud. My daughter's finishing up Girl Guides this year, so I wanted to make something special for her guiders in Girl Guides Canada. So I made up the guiding pledge. In this case, we used a speed of 4,500 and 55% power. Stainless steel. Okay, so now let's try and cut some cheap stainless steel, or sorry, engrave on some cheap stainless steel. We'll see how this guy goes. This has a curve to it, so it might not work out so well. I'm going to give it a try anyways. Okay, so one of the obvious problems is this flask is on an angle. So therefore, the lasering's not going to come out quite right, but I'm okay with it, and I'm just doing it as a test to see how well it works. So, kind of put it in the center here, lower it down a little bit, kind of even it out a little bit, and we'll see how it does. I'm going to use the new Shop and Math logo. This thing looks incredible. I love this. This is awesome. Next one, I'm going to make this a little bit higher up, and I'm going to try and burn in a QR code in the bottom maybe. leather and synthetic material. This is the first time burning into leather, so I'm only going to try it out starting at 5%, and we'll see how it goes. Interesting smell. Oh no, that's just fine. This video does not give justice to this image. It looks incredible. And some people are commenting that it smells really nice after it's been burned as well. I don't see it, but if other people like it, that's fine. For some reason, the burned image seems to be more crisp than the original digital image that I used. It looks incredible. Okay, so what we have here is we have this makeup removal cloth. I guess these guys are super expensive. It's almost like leather, but I think it's synthetic. So let's see how this guy goes here. So it's cycle start. I'm at 5% and 1,000. It's nice. It's visible. But let's try filling it in. This looks really nice, and you can feel a little bit of an indent, but it doesn't feel like it went too far. It actually feels really nice. The material is very soft as well. Very nice. Let's pull this guy up. What's the back side look like? Nothing on the back side, so it only did it on the front. That's nice. Okay, so here's the material that we've cut so far, or scribed in or burned. This guy's leather, and it's 100% leather. I got this from the dollar store for $4. This guy here is a high-end makeup removal thing. Very expensive compared to this. But they both turned out really nicely. Engraving QR codes, this technology is incredible. Okay, now let's see if the QR code actually works. So I'm going to go to camera mode here. Scan in. As soon as that bar comes up, go click. My YouTube channel shows up. And it's playing right now. The FSG A18. In this video, we are going to cover the base. Kind of cool. If you want to know how I made this symbol or anything else, leave a comment and I'll make a video on it. Photos. This looks much better done in wood than it does on a painted surface. Okay, so here's this photo here. It's hard to see. You can see the ocean in the background when you tilt it. You can see the ocean in the background that's here. But black on aluminum is difficult. Maybe another color might have turned out better. Cutting. Cutting the 15 card engraving guide. Okay, I'm cutting in inch mode, so I'm going to go 500 and 100% power. So, okay. Start. Okay, so for me to use a raised cut table, I'm just throwing a bunch of bolts down, or sorry, nuts. I've already tried it and it works relatively well and it's very accurate. I'm shocked. So instead of doing one, I'm doing a 15 pattern. It should take up most of the space here. Okay, lesson learned. Goodwill alone won't hold this thing in place by itself, so I did have to tape it down. I know it's common sense for most people, but lesson learned. This actually turned out quite well. It just very nice. Cutting a wooden decoration.
Not bad. There's one little part sticking. I should be able to pop that off from the back side. Quite a nice sign, actually. Oh, little fray there. Not bad looking. Very nice. Little fray there. If you look in, very, very clean. And I've never done any laser cutting until today. Okay, another note. Next time I need to use more than 5/8 washers. Or sorry, nuts. Because my spoil board has been spoiled.
Assembling the laser.
We got a package here. And this is exactly how the package comes in. Looks pretty awesome.
Honestly, the assembly time took approximately 45 minutes. I would have been able to knock this out easily in a half hour, but I had to go back and re-video things, so it took a little bit longer than normal. A couple of other things that I didn't mention. I set this up on the CMM machine, which you might catch a glimpse in behind where I'm doing this setup at, to test it, and this thing is incredibly accurate and has really good repeatability. I was shocked.
Okie dokie, we have all our pieces here. So now we want to find our left side and right side. So if we take a look on the side of the unit here, it tells you left and it tells you right. So that's kind of nice. Okie dokie, so we want to feed our cable through the rail. So we find the left side. If you take a look here, it says left, and the other one has a right side here. So we feed this guy through. Feed that guy through to there, and that guy just pops up here. Be gentle, don't want to pinch the wire or anything. There we go. Now this unit's actually quite big. I'm surprised. It's not really fitting on the table that well. I wanted to use all of the tools that came with the unit, but I do like a larger Allen key, so in this case I'm going to use my one Allen key. I'll use a wrench for the other stuff. Line this guy up. I'm not going to tighten it down yet. I'm just putting it in, and I'm going to leave it loose, because if you look, there's a bit of adjustment here. So I'll put a square in here afterward, and then tighten it down. So this one side's done here. I'll rotate this guy around here. Sure not to damage that one switch. So now I'm going to assemble this guy here. This is the right side. This is the right side. That guy just sits in there like that. Grab the other socketed cap screw. That into there. Leave it a little bit loose. I want to put this rail on. So this guy, I should have done it before I put this on. This just rolls in between here and rolls in between there. Set this guy on here. Just rolls right on in.
nice. Okay, so now we have this guy on here. Now the next piece, oh, I should have something else better to prop that up with. But that'll be okay. Because we're going to deal with this guy here. So upside down, again, one of our Allen keys, or one of our socketed cap screws. We'll plug that in here, put that on top. I don't know if you'll be able to see this in the video or not. Drop the socketed cap screw in. Okay, so let's do the other side here. It's the last of our 4 main bolts holding this together. And it just fits right in there nicely. I'm not super tightening it up because I want to get a square and square this up first. Okay, before I give it a final tightening, I just want to double check to make sure that I am absolutely square. So I could push it a small amount one way or the other way, but I mean, that's perfect. So I can tighten this guy down, give it its final tightness here. Keep in mind, they are only small screws. I'm not putting a lot of pressure on. Double check. Yep. Check on this side here. That's great. The design of the angle going in works really, really well. That's spot on as well. That's beautiful. Is that a nice tighten down? Excellent. See that? Excellent. Okay, now that we know that we're square, we can get rid of the square now. I want to put the belts on, the drive belts. There's 2 belts in here, one for the right side, one for the left side, and they go over top of here. I want to put this in and loop it around the drive because there's a drive in there. So let's try going in with this guy. So I'm going to try to put my belt here. Press it down. Got to start the video first. Okay. Oh, I missed the first time. Well, I got it that time. That was pretty easy, actually. And this guy here will stretch down to there. Got to put a roller in next. Alright, so grab our roller units here. We need to be specific with the bearings. So this is going to require some glasses. And I'm going to refocus in here. It's like a shoulder bolt with a locking or a Narlock nut and a pressure washer. Actually, I'll just unscrew this all the way. Nice. It's got a little bit of play in there. I guess I didn't need to, I did because the wire's in the way a bit. Okay, so I can turn around and screw this with an Allen key and that won't turn. But before that, I want to put the pusher screw here, which is this guy here. Hopefully you can see that. Just feed that in a small amount. Make sure my belt isn't twisted. Just leave that over there like that. Don't want to tighten it yet. And that puts tension on. But I don't want to put that on yet because I have to put it into here. It has to go in between these grippers first before I tighten it down fully. So just slide this into there. And that's okay. Tighten the tension up here a little bit. I do have a tensioning tool, which you don't want to put too much tension on. And I'll show you a couple tricks to using a tensioning tool if you don't have one. There, feels good. I'll readjust this after. Just get it set up for now. Now to do the other side. On a belt like this where you can't use your traditional belt tensioning tool, so what you can do is use, let's say, a few quarters or a couple nickels or dimes, and you stack them on top of the belt, and you measure the deflection on one side, put the weight on the other side of the belt and measure that deflection, and if they're both the same, they both have the same tension on them. Okay, so I'm going to try to put this in without blocking it too much with my fingers. But there's 3 ports here. This one goes into the first port. And it just slides in like that. Don't want those wires rubbing up against the belt. And now it's time to flip it over, right side up. Okay. This is a very well-built machine. It's very firm. And it's bigger than what I thought it was going to be. So it's right off the edge of the table. Okay, so we have the main wire yoke here. So let's uncoil this first. It's the big wire. Nice thick casing on here. It's almost rubberized. Straighten that out a bit, and it's got the X axis clearly marked, C, L, and Z. Your main channel here, and I'm guessing that this guy here is the laser power. So pull the laser out. And there's a note in here. Do not assemble air nozzle when air pump is not connected. I got a solution to that as well. There's a nice little kickstand there. Nice. Real nice. So this is where you put the air nozzle in, or the air adapter into. And this guy here is this laser. Okay, so let's assemble some of our wires. So I'm guessing that this guy here goes. Okay, so I had a little thing where I couldn't see because the camera was out. So basically this is where the main yoke goes in. The X gets plugged into here. The L gets plugged into here for the laser. And then we'll tie this off on the outside edge. Okay, so I took the thumb screw, put it into here. I want to set this onto here just so I know where to tie my cables down to. Now this is keyed here, so you want to make sure you put it in the right spot. And if you're a guy like me who needs glasses, put your glasses on because it's a small little key. So the key is here, so I want to make sure that when I plug this guy in, that guy sits there. I want this guy to be able to go all the way over to here. So when I put my wire ties on, it won't interfere with anything. Okay, so around there, and I'll put my little zip ties in and we'll be good to go. While I was assembling this, I had a great idea, or what I thought was a great idea. Instead of having the wire just lay loose, why not 3D print cable tracks for the wire to sit in, and then it would fold up like on a CNC machine. The only problem with that is when you add extra weight to this, because this machine moves at 20,000 millimeters a minute, it moves incredibly fast. And by adding extra weight or drag onto the head, you might not get the accuracy, or it might be too much pressure on the servo motors. Okay, for a second there I thought this didn't come with a micro SD card, but it came with a USB stick. I thought, okay. And then I looked in the instructions, and you have to pull this out of here. It's hard to see because it's black on black, right?
Yeah.
Then we put this into here. There we go. Now I'm installing the Wi-Fi antenna. I'm installing the stops to zero the machine out, one on each side.
Okay, let's try our first startup here. Pull this away here, press and hold. And it's moving perfectly and zeroing out. And that's homing. So I want to make a removable and replaceable layout board. This isn't really a spoil board. So what I did is on the feet here, I made these guys. They're tapered holes and it'll hold the feet in place. And I'm going to put two-face tape on here to stick it down to the board. Then I can remove the laser and then put it back every time in the exact same spot. So I am going to have to cut this sheet down because it's a little big. It's aluminum. It's nice and light. So I'm also going to paint this here, and then I'll be able to scribe the lines in with the laser, and then it'll be repeatable. So when I take the laser off and put it back on, it'll go in the exact same spot every time.
This is how I made the foot pads. I will also add a link to the STL file in the description. What we have here is a foot pad rest or locator for the laser. So we 3D print this, and we put 4 down on the spoil board and glue them onto the spoil board, or we can screw them down. This notch here is because on the back of the machine there's 2 screws that are really close to the foot pad, and to have the foot pad sit on here you need that clearance for the screw. So the feet fit in nice into the taper. It's about 26 inches long, so I'm going to make it 26 inches by whatever the width of this plate is here, and I'm going to take it to the shear and I'm going to shear it now. And there's some burrs on here, so I'm going to take a file, I'm going to hit it with a file, and I'm going to hit it with some sandpaper, and for the corners I'm just going to make them a little bit rounder. Okay, now this guy's all sanded. What I want to do is clean it. So I'm going to use some alcohol to clean it. 99%. Okay, this room's a little bit louder. This is a ventilation room for the welding area. So what I'm going to do is I'm just going to do a light coat, and I'll come back in 10 minutes and do another light coat, and that should be good enough for what we're doing. I laid out cardboard so nothing else gets spray paint on it.
Our feet are on. So when we lift it up, the feet will stay. And we have a permanent placement for our grid sheet.
Programming software. For software, I decided to go with Lightburn. The unit does come with Gerbil Laser, and it's free. I decided to pay the extra amount because the learning curve is shorter with Lightburn, and it seems to be a really good program. You can do a free trial download for 30 days. There's lots of information on the internet. This guy, Louisiana Hobby Guy, makes some really good videos on how to use Lightburn. Thank you for taking the time to watch the video. It's much appreciated. If you have any comments, please leave them in the comment section if you have any questions. This video was shot over the period of about a week, so the turnover time from going from not knowing how to use a laser at all to being able to produce all the stuff that you've seen was very short. It's a really easy learning curve, not a steep learning curve. So I really enjoyed playing with this. I didn't get to as many projects as I would have liked to have. There's probably about a dozen more little small projects around the shop that I want to engrave and make signs for. I'm also posting a bunch of links in the description, so take a moment to check them out as well. As always, please like and subscribe. It's free and it'll help me out. Thank you and have a good night.